To discuss the next chapter in American space leadership, please welcome to the stage Maria Zuber, E.A. Griswold Professor of Geophysics and Presidential Advisor for Science and Technology Policy at MIT, and Ashley Pilipiszyn, Founder and CEO of Besxar. The conversation will be moderated by Kari Bingen, Director of the Aerospace Security Project.
Good afternoon, everyone. It's great to see you, and I know we'll have more folks joining us as the conversation progresses. I'm Kari Bingen. I'm with the Center for Strategic and International Studies, leading their Aerospace Security Project. Let me set this up today. It is such a dynamic period in space right now. We talk about commercial space stations, commercial missions to the moon, and private citizen astronauts. How Starlink and commercial imagery has helped Ukraine to help David fight Goliath. We're seeing the commercialization of missions that we used to only think governments would do. Signals collection, space situational awareness, on-orbit servicing. We have a new military service, the United States Space Force. And with the importance of space, especially to national security, we're seeing growing threats, from cyber attacks and jamming to missiles and even nuclear anti-satellite weapons. We're now talking more about space defense, space weapons and warfare, and even space-based interceptors with the Golden Dome announcement out of the administration. So to discuss the future of American leadership in space and examine how scientific exploration, commercial innovation, and national security strategy are converging to define the next era of space policy, capabilities, and global influence, I'm pleased to be joined by Maria Zuber, Presidential Advisor for Science and Technology Policy at MIT, my alma mater, so it's great to have her here. And she is the former Vice President for Research at MIT, leadership roles in multiple NASA scientific missions, including as the principal investigator of the GRAIL, Gravity Recovery and Interior Laboratory mission. And I was really impressed. Discover magazine named her one of the 50 most influential women in science, so really privileged to have her here today. And then Ashley Pilipiszyn, Founder and CEO of Besxar, which I know you'll talk about here, an applied scientist turned entrepreneur, deep tech investor and certified pilot with a career that spans energy, including grid resilience, compute, and was the first technical director at OpenAI, and now has founded her own company at the intersection of these areas. So we'll start optimistic and then we'll go dark. But let's talk opportunities. The technology trends that you're seeing, and really the convergence. I mean, we're here at a conference and a panel to talk the convergence of space and AI. What is the convergence of technology trends you're seeing? What are the potentialities when you bring together space and AI? And what are those hard problems that these advancements will enable us to tackle, whether it be national security, space science, maybe that commercial killer app? So Maria, can I start with you? What are you seeing?
Well, sure, and thank you for hosting us here. You know, I'm overwhelmed with the idea that it's about time, okay? Because for those of us who grow up wanting to explore space, I mean, for decades after Apollo, we were just stuck in the mud with launch vehicle costs that made it really difficult to get to space, and space was really the domain really only of superpowers, okay? Then we had an evolution that space is the domain of countries. And then a breakthrough, well, we have launch vehicle costs that have decreased by an order of magnitude or so over the last 15 to 20 years. There might be another order of magnitude in there, we hope. But now the proliferation of small sats and CubeSats has made it possible to do things that we haven't been able to do with large spacecraft, okay? And the important thing here, so you've got things like, you know, better communications, okay, better data storage on them. A really important one is better pointing and stability, so that these small satellites can essentially do the things that the big boy satellites have been doing. And the important thing here is that it de-risks these platforms, okay? It's not everything in one basket, and if you lose it, you lose it. You really lose it. And so because of that, we're starting to have the democratization that we've wanted to have for space, with more and more people able to get access because the costs are coming down, because the risks are coming down. If you think about it, anybody with a credit card now can ask a satellite to take surveillance in commercial entities. So then the next big thing here is AI, okay? And AI is going to be central in operation, in design, and also in the security of space platforms. It's already happening, and I guess the one thought that I want to leave, this is an AI conference, you're out there thinking about how can my AI work in space. I think the really critical thing here is that don't just think that you can write a program and it's going to be okay, okay? It's going to be really important. Space is a harsh and it's an unforgiving environment, okay? And so if you really want your software to do the job that you want it to do, you've got to have a great understanding of the space hardware that you have. And you also have to have really domain knowledge of the science of the space environment that you're operating in. So you bring those three things together, and I think that's a formula for success.
Great, thanks.
Yeah.
Ashley.
I mean, to follow on that, I think one of the biggest opportunities is if each of you and everyone in the audience were to think of your favorite sci-fi or space-based movie, at the end of the day, I'm willing to bet that either there's some type of robot, there's some type of onboard computer, there's some type of AI system that we've been talking about for decades. The cool thing is, now we can actually go and execute and make these incredible technologies a reality, and it's already happening. We're seeing so many advancements for different types of, compute, in low Earth orbit, all the way to looking, on the moon, et cetera. So what is able to be unlocked from leveraging AI in space systems, in space technologies, and this core integration is enabling us to be able to do things that we've only dreamed about, that authors have only written about, but now we can actually go and build it. And that, I think, is probably the most exciting thing that's possible. And to build on what Maria was saying, not just being able to take your credit card and book a launch, but actually being able to do that on a repeatable basis and being able to create that accessibility for many other people to do really interesting things, whether that's in-space manufacturing, new types of different experiments that can be run, exploration, and at the end of the day, the data that's being collected and what we can do with all this massive amounts of data, and that's where AI can really play a role. And the last thing I'll say is, whether it's robotics or onboard autonomous systems, these are the systems and technologies that will go ahead of us for human exploration and as we want to venture further as well up to this frontier.
Well, and we can't have a conversation about space these days, or frankly AI, without talking about China.
Yes.
So I do want to tee up, is America leading in space?
The answer is it depends, and more importantly, on which aspect of certain space technologies. When it comes to launch, America is ahead, full stop. We're in the lead there. When it comes to other types of critical technologies, you look at what China has been able to do on their space station. There are things that we should be able to advance even further, whether we're looking at onboard compute, looking at other types of manufacturing and scientific technologies. We need to ramp up our game and take it a little more seriously.
Well, as you look at that intersection between space and AI,
yes.
Where is China at, say, vis-a-vis the United States and our companies?
To be honest, what I'm seeing is China is taking the lead, and that is a little scary in being able to advance not only these AI models, but how they're deploying them and the applications and capabilities that they're taking forward. And so I think it's important for us to be able to look in the mirror and say, okay, we have to address this. This is actually a serious threat and competitor. And that's where I think we need to be able to work together with government, other companies, industry, et cetera, to advance this even further.
And Maria, you see world-class research. What are you seeing, and what's at stake here?
Well, let's stay in space with China. the last time that the United States brought samples back from the moon was in the 1970s. China brought back samples from the far side of the moon, okay, within the last couple of years. So, so they've got an active program, they have an ambitious program, and they are executing on it. And so at in the universities, what we're seeing, well, right now there's a great deal of disruption associated with possible budget cuts. It's not at all clear what the level of those cuts will actually turn out to be, because the appropriations is done by the Congress. It's not the president's budget is a recommendation for a starting point for the negotiations. But the benefit of, let's take NASA, the NASA space programs, they have benefited from a mix of, I'll say, small spacecraft, rapid launches, with flagship missions that really, really push the technology. And so these large missions, and let's just take the James Webb Space Telescope as an example for that, that's a one-off, had NASA involvement, had significant industry involvement, but developed many, many capabilities that are then available for both other NASA missions, but also for more commercial involvement. And the benefits go back and forth. So part of what goes on here is that we need to have a healthy aerospace industry with both the large players and the startups, and room for the startups in there. And you need them both in order to make it work. Just like you need both the government and the commercial enterprise to make things work. Because on the government side of things, there is an awful lot of expertise there. And it's hard to do things in space. If we're going to make mistakes, let's make new mistakes. Let's not make the same mistakes that we made before, because these mistakes are expensive to make.
Yeah, that's a great point. You know, one of the themes and observations from this conference overall is that so much of the technology innovation is happening within the private sector with private capital, not necessarily in government. That's where these AI advancements are happening. You're seeing the same happening now in space, and Maria, you laid out some excellent examples in the outset. So when you think about what role should the government have, you know, through policy and investment, they can nurture and incentivize, they can buy, they can limit. What role do you see the government playing in this, you know, AI space nexus and ecosystem?
Well, I would say, you know, if I had to pick one word, I would say enabler. Okay, what can the government do to remove barriers to allow the private sector to operate? So one thing that I think is that the government is sometimes too hands-off on the commercial industry when it has expertise that it could be adding to the situation, and yet a contract is given and there can't be any involvement at any level. And but there is knowledge there. I mean, we've had some commercial landings on the moon where we've had spacecraft that have landers that have tipped over. Okay, there are people out there who know how to make landers not tip over when they land on the moon, and it ought to be easier to get them involved to do that. But on the other hand, anything that industry could do, industry should do, okay? And the government should be there to provide support to enable that to happen, and then to incentivize to make it work better. So certainly the government should never build more than one thing.
Well, and I think that's a perfect segue. And Kari, we were just talking backstage about this beforehand. Is I think the best thing government can give startups and industry, but primarily startups, is speed. Let startups own the velocity and take as many shots on goal and move as quickly as possible. And don't take shots on goal for the sake of taking shots on goal. They need to be calibrated, and you need to learn from each one and learn as quickly as possible. And I think that's the biggest thing is time. The timeline that a government contract takes to go from awarding to execute versus the type of iteration speed that startups need to be operating at, they're completely mismatched. And so being able to actually dial those in so that actually there can be alignment in terms of the velocity, lessons learned, be able to unlock new milestones, and to tie it all back to where does AI fit into this, I think that's actually by being able to have more companies, whether they're space companies, other industries as well, take whether that's an AI first approach or AI enabled approach to their own company operations, as well as their technologies as a whole. So we're seeing this integration, and so to unpack this one step further, also to look at the future of policies and what we're seeing play out, because one of my fears or the trends I'm seeing is, everything related to space we see over in this sandbox, and everything related to AI, in a vacuum is over here. And the reality is we need to take a much more integrated approach on what the application layer is for the use of AI and how it's being deployed. And so I think as more companies begin to leverage AI for whether space operations or things like that, being able to take a more integrated approach to the way we're looking at policy. And so one of my hopes or actions on my dream wish list would be, I think the FAA has done a fantastic job with the idea of learning periods. We need to apply that to other technologies, particularly as we think of integrating AI to the space industry, nuclear, other types of energy, other types of applications, quantum, et cetera, and look at it from that type of lens versus writ large.
Yeah, and if I could just add to, I loved what you said about lots of shots on goal, okay, and certainly the whole idea of the fail fast, try something, hopefully it works. If it doesn't, collect a lot of data, look at what went wrong, fix it. That works great if you're trying to put something in low Earth orbit or maybe even geosynchronous. It doesn't work so well if you're going to the moon or if you're going out to L2, James Webb Space Telescope.
Yeah.
We don't have the ability to fail fast on that.
Yes.
That's one where you really need the government involvement and the oversight in that, because we're only going to get one shot at it. And I actually helped out with James Webb a little bit, and to this day, it's still a miracle to me that we got it to work.
The data coming off of that is just phenomenal. So it was interesting. I was in the Baltics last week attending a drone conference where the Baltic countries, the Brits are working incredibly closely with Ukrainians to help get scaled, manufactured drones into the field. And just one of the observations, back to your point on speed, is Ukrainians are operating on a week's, 40-day innovation cycle, whether it be software or hardware.
Yeah.
Now, you could say space is a bit different. That it takes a while to build these things, but what can we adopt from that? Are there some gold standards or best practices?
Absolutely. Hot off the press, I was just seeing the latest numbers. I think SpaceX now is launching every 1 point. It's either 2 or 8. It's less than 2 days. I can't get my Amazon Prime deliveries that fast anymore, but yet we can, go to and from space in that type of cadence. So I think being able to realize that what cadence actually is possible today, and that yes, space is hard, and there are some things that are going to take longer than others, but for a lot of other applications, we can move way faster than we've realized, and in some cases faster than terrestrial applications of that same supply chain, for example.
And it may be a different risk calculus too. What do you see, Maria, with those?
Well, even the kind of in the circles that I travel on, it's kind of longer term thinking and design. But I'm thinking about Earth observations where we never thought we could really use very small satellites because they just they just didn't have the stability and the data collection capacity, and that's really changed now. And so there are very small satellites that are monitoring, say, tropics as an example, which is collecting data on the Earth on the formation of tropical storms. And so this it's all beginning to happen much faster, and AI is going to further facilitate that. So it's thrilling to see.
So when I was at the Pentagon, I was privileged to have the Project Maven team under me, which was an AI pathfinder looking at full motion video. And that team was really instrumental in a line that was in the 2018 National Defense Strategy. So I'm going to quote it, and Ashley, turn this to you. So the line goes, "Success no longer goes to the country that develops a new technology first, but rather to the one that better integrates it and adapts its way of fighting." So how are we doing on that integration and adaptation front, whether we're talking warfighting or space exploration?
We're doing okay. There's a line from Chernobyl, the series that, not great, not terrible. I'd say that's probably about where we're at. I think we are doing a decent job. We could definitely do better. And the example you gave, even from your recent trip, being able to up those iteration cycles, take those learnings and feedback, leverage AI for as much data collection as possible, and turn that into action, as well as how you're actually processing and using those insights as quickly as possible. So that compounding value of a flywheel to actually move from, okay, here's an idea, let's build it, let's test it, let's iterate, let's go. And being able to do that on a regular cadence much more quickly. So that goes to the how are we adapting a certain technology and how are we integrating it. The other thing on integration that I want to bring up is when we say integration, not just integrating a particular technology, but a capability. And so one of the things, in our case of in-space manufacturing, looking at how we think about supply chains and integrating much more what is happening in space and how it relates to supply chains terrestrially. We take GPS for granted, and everyone is using, different technologies, but that linkage isn't quite there for everybody. And I think being able to actually understand how different space technologies are part of these larger supply chains we're seeing both in defense and in the commercial sector as well.
Yeah, if I could just add to this, this is really an area where the advances in the commercial sector are helping the scientific observations, okay? Because, somebody like me who would try to write a proposal to make some space observations at this planet or some other planet, you've got to ask a good scientific question, which is actually not that hard. But you've also got to have the best risk profile, okay? You want to minimize the risk, which means that you don't want to do anything new that you don't have to do, okay? And so you want to use capabilities that have all been proven in space before. And if you want to introduce a new capability, it's a pretty tall hill to climb. So the kind of things that you're talking about, where you try it, you put it up there, you collect some data, once that gets proven, it really improves the risk profile for,
Yep.
especially if you're dealing, I do lasers in space, and if you do with active sensors, anything that you can do to reduce risk and demonstrate an active sensor is really, really great value added.
Well, I want to shift gears a bit. Maria, you and I were talking beforehand about just the workforce and the talent base. And with the diffusion of technology, talent, capital, that's long been our strategic advantage. How do we retain that in this day and time?
Yeah, absolutely. Well, it's, I'll tell you what, it's so inspiring walking around here and seeing all the young people. And I'm, of course, dedicating my career to that up at MIT, training the next generation. But for us, if we think about it in terms of space, AI, national security, where we will be at our best, as I told you before, we're best off if we collaborate, if we use the best that we have from the private sector, from FFRDCs where they're appropriate, and from the government. And so you want to use those in all the ways that are appropriate. And if you want to use those in all the ways that are appropriate, the workforce in a given area has to understand how these different parts all work, so we can understand how to best formulate a collaboration that is optimal. And so that means making it easier and facilitating a student coming out and graduating who can work in one sector and then easily transfer to another and easily transfer to another. And I'll just say, and I'm sure most of you are aware of this, in China, everything is connected. You know, the government is industry and academia. It's all part of the same thing. And there are no, you know, artificial barriers between. There's just complete sharing of information within those sectors. Whereas here we have artificial barriers. We have conflict of interest and things like that. So those have to be managed. They're not to be ignored because they're important. But let's just look at them and be sensible about how we do them to make it easy for somebody in industry to go do a rotation in the government or go to an FFRDC and say not have to, you know, get rid of every stock they have in everything that isn't totally relevant to the job that they're doing. I think it deserves another look to make just easier for our young people to develop their careers in the broadest ways possible.
It's a really, really great point. You know, Ashley, the panel theme here is the next chapter in American space leadership. When you and I met months ago and you were talking about what you're doing now, I mean, it was an area that I just was floored that we were even considering doing in space. So we talk about how can we leverage the space domain to do very new and innovative things that maybe only governments would consider or finance, but yet you're doing it. Can you talk a little bit about that and maybe some lessons learned for being the new kid on the block doing something very imaginative?
Yeah, no, absolutely. And I think, you know, again, it goes to, we truly do stand on the shoulders of giants, and I've noticed this interesting trend that a lot of people have started asking the question, why all of a sudden are we picking up projects that were left on the cutting room floor or stuff that was started in the 60s, 70s, 80s, why are they coming back again? There's a couple different answers, but at the end of the day, looking at what you can do with AI that wasn't possible before, and being actually able to streamline a lot of these different, manufacturing lines, et cetera. And so I think that's an exciting capability that you could take forward. And so from our case in point, what we're really building off of is what was done in the early 2000s in the late 90s called Wake Shield Facility. Most people don't know about Wake Shield Facility. I hope some people have heard about it. Fun fact is it was NASA's actually most cost-effective project. Wake Shield Facility cost less than $12 million and went from idea to launch on Space Shuttle in less than 60 months, which is incredible, especially for NASA at the time. And when you're looking at launch costs at the time were about, I don't know, 12K a kilogram or so. And so the whole goal behind Wake Shield Facility was you open up the payload bay door of Space Shuttle, and literally they had a giant 12-meter diameter stainless steel shield that then they dragged behind Shuttle to create a ultra-high vacuum in the wake of Shuttle to be able to do deposition of semiconductor wafers. We did that. We have already done that in the 90s and 2000s. And so being able to build off a lot of this technology of, okay, a lot of the technology, the science was proven out. How do we scale that to go even faster? How do we actually leverage a lot of these AI systems to help us with things like failure analysis, defect control, all of these different aspects? So I think that's what's really exciting is for projects like Wake Shield, et cetera, how do we even push the envelope even further when now we can go to and from space at such a regular cadence thanks to a lot of the launch providers today.
I love that. We're so used to thinking about exquisite things in space, but now thinking about mass scaling, manufacturing, these large constellations.
I mean, there were so many good ideas that were before their time, and now we have cheaper launch costs.
Yeah.
We have very capable small satellites, and we've got AI to help us. So I think the future looks bright.
Okay, so we're going to wrap here. I want to give each of you the last word, and also, let's make this discussion actionable. So if there were one thing, maybe one homework assignment for all of us here on what is the most critical action or the one thing that can be done to advance leadership today, what would that be? Maybe Maria, I'll start with you. And then.
Yeah, no, I talked about this a little bit, but in terms of action, let's look at the rules of the way that the government interacts or not interact with industry in order to facilitate and move things quicker. I think that I think it deserves a look, and also to in terms of the workforce to be able to figure out what workforce the government needs to have, and then to have domain experts responsible for choosing the people with the right expertise. In this case, not having, just going looking for keywords on resumes. So,
to build off of that, I think, if there's one thing to take away from anything I've said, it's that in-space manufacturing is American manufacturing, full stop. It's part of our supply chain. We need to integrate that more holistically and take it seriously that, space isn't just off here in its corner, and then what's happening in AI is off in its own little corner. It's one integrated system, and we need to view our supply chains as such.
Well, thank you both. You both have had such distinguished careers in science and in technology. You're bringing an entrepreneurial mindset to space and challenging us to do things that maybe we've done before in a different era and a different cost point, but really bringing those to fruition at scale now. And I think many of the themes that have been talked about throughout this conference equally applicable to the space domain and the missions that you both work on every day. So thank you both very much. Everyone,
Thank
please
you.
join me.
Thank you so much.
Round of applause.